So first, an announcement. So at the end of the industry track, which has 3 presentations to it, we'll take a small amount of time for some question and answer. We've got our industry track presenters as well as some folks from the DMN track who have volunteered for that. And we have been collecting some questions in advance already. If you look at blog.ruleml.org, which is the RuleML blog, then there is an article about this panel, and then in the comments section there are some questions posted. If you feel like posting a question of your own, you can put that in now with the Discuss feature, and you just need to get a Discuss account, which you can do for free in order to make a comment on that. Okay, and let's see, I just open the other one. I'll be presenting the first industry track paper basically on behalf of James Anderson, who is half of Datagraph in Berlin. And so we worked with him on developing a statement of a problem that's facing him in his company. Datagraph provides a graph store service, basically a cloud service, and they're small, so they try to offer some advanced features in order to establish their place among the various competitors for that. And in particular, they focus on what might be called dynamic RDF graph stores. So just from the standards, the definition of a graph store is a mutable repository of RDF graphs. So in some sense, all graph stores are dynamic, but this is dynamic with a big D. In other words, there are many small changes from simultaneous users happening in a high volume, or perhaps in response to string data, and so the dynamic nature of the graph store is really dominating what's going on there. And they would like to support some real-time features of such stores, have queries registered as views that are then get updated in real time as the graph store updates. And so that is their goal. And in addition to that, they're looking to support a related notion, which is currently just under development from the W3C community group, called RDF Stream Processing Query Language. And this group is developing the notion of an RDF stream as sequences of time-stamped graphs. Basically, the thing to picture here is that you have first of all, a time-stamped graph is itself an RDF data set, but constrained, so that you have one named graph in that, and then you have in the default graph, you have annotations about that named graph, including one particular triple that gives a timestamp to it. And then a loose definition is that in the stream, the sequence in which those timestamp graphs are revealed must respect the chronological order of those timestamps. And there's a more precise definition of that in the draft report on the abstract syntax and semantics of RDF streams. And so diagrammatically, here's what's going on there. We have a little picture of a time-stamped graph. The named graph here is in pink with the as a quad, and the fourth item there is the name of the named graph. And in the default graph, which are just triples here, you have a distinguished triple which relates the name of the named graph with some property to a timestamp, and also might provide some additional information. And then the RDF stream is some sequence of such timestamp graphs. Okay. And then we relate this to the idea of a dynamic graph store by looking at windows of the stream. So if we define a window of the stream as the group of these four timestamp graphs here, that might be considered a snapshot of a dynamic graph store, because graph stores are also about RDF data sets, and then a window of an RDF stream can itself be considered as an RDF data set. You kind of take the union of those four data sets to form one data set. And then if you slide that window over, some of the information in that snapshot expires, and some gets added, and so those are like updates to your dynamic graph store. In the new snapshot, there are some new information and some things missing. And so these two ideas, at least with this sliding window picture, are roughly the same thing. And so we're looking at solutions that address both of those. And from an idea of why DataGraph is interested in this, is simply about the market size associated with autonomous distributed sources, which is what these methods are aimed at, of aggregating various RDF streams or RDF data stores. In their estimate, really the size of this is only limited by wireless bandwidth. Overall value with 11 digits, and if you take the software costs estimated as 1% of that, you've got here $1 billion worth of market value that could be tapped into with addressing these capabilities. So they definitely want to get a foot into this market. And also their particular business drivers. Their clients are interested in integration of these diverse sources, in particular things like integrity constraints for compliance requirements, enhancing confidence, the real-time views, and managing the life cycle, again, as a contributor to confidence in the quality of the information in their graph stores. Some of the requirements, the supporting capabilities that are necessary to make this happen. The ability to modularize complex queries. So this is something Datagraph wants as part of the solution they're looking for. Their queries come in Sparkle. I don't know if you're familiar with Sparkle, a single query that's complex and involves integrating a lot of multiple sources can be just a very massive, monolithic, many lines all nested together. Very difficult to read and maintain and debug. So they would like to be able to break those apart into chunks that are more easy to manage. I really saw a demonstration of that while we were developing the examples for this. We started off with a monolithic version, which when we broke it into the various parts, we discovered the original one had all sorts of errors in it, which we just weren't able to see until we broke it into the individual parts. They want to be able to describe reactions in order to get the real-time processing. They want to be able to do that incrementally, scale, in response to size and rate, and as mentioned, support RDF streams. They're focusing on their customer satisfaction and in supporting these sort of advanced features as well as the confidence in the content. And based on what capabilities they already have, they also want this solution to be somewhat of an incremental addition to their implementation. They want a syntax close to RDF. They don't want to have to explain a whole new syntax to their clients who are comfortable in RDF. We'd like to be able to express the changes that are going to take place in the various grammars in a modular fashion. They are very focused on implementing standard systems whose semantics are supported by published and accepted standards. And as we'll see, a lot of the existing solutions don't satisfy this requirement of well-defined semantics. Naturally, get involved in remote controls. That's kind of the nature of the graph stores. Need to be able to support named graphs and RDF data sets as the inherent basis of this whole structure. And the other things have already been mentioned. Talked about some of these already. And Sparkle, again, is their main query interface, so they're focusing on extensions to Sparkle as the means for accomplishing this. Some of the options that were looked at, and I'm going to just run through this very briefly, approaches that have tried to address the temporal nature of this, like temporal RDF, R&W base, R34 poles, however you pronounce that, C Sparkle, C Quells. When compared to all these requirements, all of these existing options have one or the other thing missing. Either they don't support data sets, they have a process model which doesn't lend itself to incremental processing, and so on. Some additional options were RDF stream options, such as Sparkle Stream, EP Sparkle, Instance, Diachron. Again, either did not support data sets or don't have an open semantics. And here's some rule-based options considered as well. Spin, for example, would be considered probably the closest match to all their requirements, except for the fact that the semantics of spin are not actually defined, other than there is some proprietary implementation from top RAID that is basically, they say, okay, this defines the semantics of spin. And so we looked for homegrown alternatives, and what Datagraph has come up with as an option is, first of all, an extension to the Sparkle grammar, which would allow a definition of either the revision of the dynamic graph store that you're interested to focus define these windows. To illustrate an example of what's intended to be accomplished from this result, here's just a diagrammatic view of a Sparkle query. That the full query is contained in the proceedings, but this is just a pictorial view based on a healthcare query about a connected patient that's hooked up to a couple of sensors having to do with measuring heart rate and also measuring motion. And the idea is to construct an alert in case there's an unusually high heart rate in the context of the sort of activity that the patient is undergoing. So if they are exercising, the threshold for what constitutes an unusually high heart rate is more than if they are just lying on the couch or not moving around. And so combining these various sensors, in addition to some background knowledge about the patient and the business logic associated with calculating this concept of unusually high heart rate. And so this is just a summary of the implementation approach. Extend the graph store protocol, extend their query processor, and extend their graph store query API. So those are the various things that Datagraph would need to do in order to implement this. And so this is again a statement of a position. So this has not yet been implemented, and it would probably not be implemented until these extensions to Sparkle or the Graph Store protocol had at least been vetted by the community. So that will be the next step in the progress of this, is to get some community buy-in to the extensions to these methods to support these capabilities. And we're also looking at the approach is based on a certain restricted set of the RDF streams called the discrete time series profile. It depends on certain characteristics, such as the stream being in a unique sequential form, and so there are other more general forms of RDF stream that we would like to consider extending the approach to the more general streams. Okay, that was the future work. Okay, questions? Thanks for your attention.
When you modularize a large query into maybe 4 pieces, this decomposition,
yeah.
Can it be used in a way that you don't need to ask the others 3 if the first already fails?
So let's see. It would the sort of natural statement of this would be declarative. So you're asking for sort of a shortcut evaluation. That's not part of the proposed grammar extension as it is now, but it could conceivably be part of the implementation. But it's an interesting idea. I think in the case where there are clear dependencies, so some of the modularization is you will pull out a subcalculation of your overall query and basically create an intermediate stream, which would then get called by a later calculation. If that stream is empty, then there wouldn't be any calculations on that intermediate stream because they would have no values in it. So to that extent, those dependencies would be taken care of.
Sliding window, is that somehow akin to parsing natural language speech left to right? Because you hear also the first part of the sentence, you already could start to parse it, but then you can also reject hypotheses.
Not really. It's not, the sliding window is not there for incremental processing. It's there for taking a snapshot. And so that window defines your theory, in a sense. That's what the query gets applied to. And then when you go to a new window, you apply the query to the new theory, the updated theory.
The grammar extension based on Sparkle 3? Or?
I'd have to check with James about that. I'm not sure. Okay. I know it was taking advantage of a very new addition to Sparkle, which we actually had to request, which is to be able to construct an RDF data set. That wasn't there in Sparkle. You could only construct a graph. And so to make all this work, we need to generate another stream. You need to be able to generate RDF data sets as well. So it must be based on whatever the latest version is.